Okay, this lesson is on interest, and it's related to our geometric and arithmetic sequences in the sense that we always have a starting amount, so we always have our a sub 1, and then sometimes the interest will be arithmetic where it has a common difference, and other times it will be geometric where it has a common ratio. So if you could look at question number 6 for right now, it says that Peter needs $200 to start a snow cone stand for this hot summer. So he needs $200. He borrows the money from a bank that charges 4% simple interest a year. So question A says, how much will he owe if he waits 1 year to pay back the loan? So if I want to figure out how much he has to pay, all I have to do is take the $200 that he borrowed and multiply that by 4%, which is 0.04. So I end up getting $8. Now, he obviously doesn't owe the bank $8. He owes an additional $8 on top of the $200 he already owes them. So he owes $200. So here's my a sub 1 plus an additional $8, which is $208. Okay? Now, in question B, it says, how much will he owe if he waits 3 years to pay back the loan? So this time, I'm going to take 200 and I'm going to multiply it by 0.04. That's for 1 year. And then I would multiply that by another 3 because every year he owes an additional $8, right? So this would end up being $24. Now, if you think about it, if 1 year he owes $8, the second year he would owe an additional $16, the third year he would owe an additional $24. So altogether he would owe $224. Now it says write a formula for the amount he will owe after t years. If you think about it, if he starts at owing $8 and then he owes 16 and then he owes 24, we have a common difference of 8, which means that this is going to be an arithmetic sequence. So if I wanted to write a formula for the amount he owes after t years, this would be easy because all I have to do is think about it like this. F of t is equal to, he owes 200 no matter what because he borrowed it, plus an additional $8 per year. Okay, so hopefully that makes sense to you. But this is the question, where did this 8 come from? It came from taking the initial amount and multiplying it by, so here's my initial 200, then I take the initial amount, I multiply it by the rate, which is 0.04, and then I multiply it by the time. So this right here is going to be my formula to figure out what it is. This is the simplified formula, but this is where you get it from. So if we go back to simple interest, our simple interest is going to be equal to the initial amount, which is the P. So I want you guys to write yourselves a note. That P is the initial amount, which is the principal, multiplied by the R. So I'm going to multiply this by the R, which is the rate, and multiply that by the t, which is the time. Okay, so this should make sense to you because we did this right here. The principal was 200 because the principal was the initial amount. 0.04 was the rate because that's how much the interest is being charged at. And then t is the time. In this example, our t was 3. All right, and then we added an additional 200 because this formula only tells me the interest. The total amount would be the interest plus the principal times the rate times the time. All right, let's look at number 7. It's going to be slightly different, but first of all, I want you guys to change this invest right here into to borrow. He's going to borrow $500, and the bank gives an interest rate of 6%, but this time it is compounded annually. Now, when it's compounded annually, it's slightly different than simple interest. So if you noticed when we had simple interest, every year he's charged 4% of the $200. It's not based on the amount of money that he has to owe total. So even though after 1 year he would have to pay $208, after 3 years, the percentage is multiplied by the initial $200. When it's compounded annually, it means that you take the amount that you had before, so like in year 3, I would take the amount of money I had to pay in year 2, and I would take 6% of that amount as opposed to 6% of the original amount. So let's skip through A and let's do question B. How much will he owe if he waits 1 year to pay back the loan? Now, if you remember from the last video, we said that we could multiply 500 by 6% and then add an additional $500 on to figure out the total amount. Or I could just multiply by a whole and another 6%. So that tells me the total amount that he owes. So if you multiply that through, Jack would have to pay $530 to pay back the loan. All right. And then question C says, how much will he owe if he has to wait 3 years to pay back the loan? So I would take the $530 and I would multiply that by 1.06 again. This is going to tell me how much I would have to pay after 2 years. All right. And then I would take that answer and multiply it by 500 or 1.06 as well. So when I take 530 and multiply it by 1.06, I end up getting $561.80. Then I would take 561.80 and multiply that by another 1.06. So let's go ahead and figure that out. 561.80 times 1.06. And you end up getting, sorry about my writing, $595 and 51 cents. Okay, so notice how when it's compounded annually, I multiply the 1.06 by the new amount, not the original amount. Okay, remember the formula, or remember in the last video we talked about how the shortcut is just to take my initial amount and to multiply it by 1.06 to the third power, because I'm multiplying by 1.06 3 times. So 1, 2, 3. So I'm going to multiply this by 1.06. It's going to be raised to the third power. So let's go ahead and figure out what that's going to be. And you should end up getting the same exact thing, which is $595.51. Okay, so we'll write down that that's what it is. So we can go back and write our formula for the amount that he owes after t years, and we'll just say that f of t equals 500 times 1.06 all raised to the the t power, excuse me. So based on however many years you have, that's the number that you are raising the 1.06 to. All right. All right, now let's revisit our formulas. Hopefully compound interest, we can figure out what the formula is going to be. But here's the thing, this only works if it is compounded annually, okay? There are other types of compounded formulas, but we're only going to look at what happens if it's compounded annually for right now. Later on, we'll go in more in depth with that. And what that's going to be is the amount of money that you have is going to be equal to the principal, your initial amount, multiplied by 1 plus the rate, so nothing is new, all to the t power. And hopefully you understand the difference between when you would use simple interest and when you would use compound interest. Okay, in number 8, it asks you, if you have $200 to invest for 10 years, would you rather invest your money in a bank that pays 7% simple interest or 5% compounded annually? Okay, so we're going to use both formulas. In the first formula, you know that the interest is equal to the principal multiplied by the rate multiplied by the time. So that's going to equal 200 multiplied by 0.07, and then the time is 10 years. So I'm going to go through and I'm going to figure out what I get when I multiply all those numbers together. So you end up getting $140, which is how much you get in interest, but you also have an initial $200. So your final answer for this would be 200 plus $140. So you end up getting $340 after 10 years using simple interest at a rate of 7%. Okay? I need to figure out now how much I would pay, or sorry, how much I would get if I invested this money at 5% interest. So let's go ahead and see what we would do for that one. So I'm going to figure out what f of 10 is when the principal is 200 multiplied by 1 plus the rate. In this example, it's 0.05, all raised to the 10th power. All right. Now I'm going to just have this a little bit more simplified. So I'm going to say f of 10 equals 200 times 1.05, because I can combine these two numbers together, all raised to the 10th power. Go ahead and figure out what you would get for that, and let's see what you are. Let's go from there. End up being $325 and 78 cents. Okay, $325.78. So in this example, I would rather have simple interest at 7% for 10 years because this is a higher number. So this is the one that I would prefer. But here's the thing. Remember when we graphed out all of our different functions when it was a linear function versus an exponential function, and it ended up looking more like this right here, where this was one of my functions and then the other function ended up looking like this, the exponential one. So eventually you will get to a point where the exponential one will be better. We just haven't gotten to that point yet here in this example. But if you tried to compare it for 20 years, I bet you that you would much prefer the compound interest versus the simple interest. All right, I would like you to read through number 9 and try it on your own. Let me give you a little hint that will help you out. First, create your formula. Figure out what your formula should be. Then, once you figure out what the formula should be, go ahead and use guess and check until you get to 3,000. All right? So formula and then guess and check. When you are in higher level math, once you get to Algebra 2, you will learn how to use something called logarithms to help you figure out what this answer is going to be. But at this point in time, we don't know how to solve equations with variables in the exponent, so you can just use guess and check to figure out your answer. All right, we will talk about this next time I see you in class. I hope you have a wonderful weekend. See ya.